Today, we are going to be solving a series problem that is typically taught in Calculus 2. This problem states if the nth partial sum of a series n equals 1 to infinity of a sub n is given by the equation s of n equals n minus 7 over n plus 7, find a sub 1, a sub n, a sub 5, and the sum of the series as n approaches infinity. Feel free to pause the video and attempt to solve this problem on your own. Otherwise, let's jump right in. What we'll first do is set s of n equal to a sub 1 plus a sub 2 plus a sub 3 all the way to the nth number of terms. Remember, our s of n is the nth partial sum, so we will have n number of terms added together. Therefore, to find a sub 1, we set n equal to 1. This gives us s of 1 is equal to a sub 1. Next, let's use the equation given and plug in 1 for n. We get a sub 1 is equal to 1 minus 7 over 1 plus 7, which is equal to negative 6 over 8, which is negative 3 over 4. Next, let's solve for a sub n. We know that s of n is equal to, we just need to isolate our a sub n term on the far right. The way we do this is by solving for s of n minus 1. This is equal to a sub 1 plus a sub 2 plus a sub 3 plus many more terms all the way to a sub n minus 1. Now, let's subtract these two equations together. We get s of n minus s of n minus 1 is equal to, well, all these middle terms actually cancel out, so we're left with only a sub n, which is what we're solving for. Now, let's plug in values for s of n and s of n minus 1. We get n minus 7 over n plus 7. To find s of n minus 1, just plug in n minus 1 for n. We get n minus 1 minus 7 over n minus 1 plus 7, which simplifies to n minus 8 over n plus 6, making this our final answer. So what we did in this last step is we derived a formula for a sub n for any value of n. The derivation of this formula s of n minus s of n minus 1 is equal to a sub n is definitely worth remembering because it allows you to solve for any a sub n value given a formula for the partial sum. Now, let's use this formula we just derived to solve for a sub 5. We let n equal to 5 and plug in the correct values, and we get s of 5 minus s of 4 is equal to a sub 5. So our s of 5 is 5 minus 7 over 5 plus 7, and our s of 4 is 4 minus 7 over 4 plus 7, which is equal to negative 2 over 12 minus negative 3 over 11, which is negative 1 over 6 plus 3 over 11. So our final answer is negative 1 over 6 plus 3 over 11. Lastly, let's solve for the sum of the series from n equals 1 to infinity of a sub n. So this is going to be the limit as n approaches infinity of a sub 1 plus a sub 2 plus a sub 3 plus many more terms all the way to a sub n, which is going to infinity. So we know that this series is equal to s of n. And so what we're solving for now is the limit as n approaches infinity of s of n, which is equal to the limit as n goes to infinity of n minus 7 over n plus 7. As n becomes larger and larger and larger, these two constants will essentially go away. And what we're left with is really just infinity over infinity, which is 1. So the sum of this series from n equals 1 to infinity is just 1. You can also confirm this using L'Hopital's rule. The derivative of the top is 1 and the derivative of the bottom is also 1, so 1 over 1 is just 1. Today, we learned how to calculate any a sub n term and the sum of all terms in the series given the nth partial sum of a series. I hope you enjoyed watching. Stay tuned for more content.